A sea breeze or onshore breeze is any wind that blows from a large body of water toward or onto a land mass. By contrast, a land breeze or offshore breeze is any wind that blows from a land mass toward or onto a large body of water. Sea breezes and land breezes are both important factors in coastal regions' prevailing winds. Sea breeze and land breeze develop due to differences in air pressure created by the differing heat capacities of water and dry land. As such, sea breezes and land breezes are more localized than prevailing winds. Since land heats up much faster than water under solar radiation, a sea breeze is a common occurrence along coasts after sunrise. On the other hand, dry land also cools faster than water without solar radiation, so the wind instead flows from the land towards the sea when the sea breeze dissipates after sunset. The land breeze at nighttime is usually shallower than the sea breeze in daytime. Unlike the daytime sea breeze, which is driven by convection, the nighttime land breeze is driven by convergence. The term offshore wind refers to any wind over open water, which is related to but not synonymous with offshore breeze. Sea breeze, a local wind system characterized by a flow from sea to land during the day. Sea breezes alternate with land breezes along the coastal regions of oceans or large lakes in the absence of a strong large-scale wind system during periods of strong daytime heating or nighttime cooling. Those who live within 30 to 40 kilometers, about 19 to 25 miles, of the coastline often experience the cooler 10 to 20 km, about 6 to 12 mile/hour winds of the sea breeze on a sunny afternoon, only to find it turn into a sultry land breeze late at night. Since the surface flow of the sea breeze terminates over land, a region of low-level air convergence is produced. Locally, such convergence often induces the upward movement of air, fostering the development of clouds. Such clouds may produce showers that occur over land in the afternoon. Sea breezes occur on summer days because land heats up faster than the sea. Warm air rises as it is less dense than cooler air. As the warm air rises, cooler air from over the ocean moves over land to take its place. It is this movement of warm and cool air that creates a sea breeze. The opposite happens at night when the surface of land cools faster than the surface of water. The warmer air over the ocean rises and cooler land air flows out to sea to replace it. Sea breezes are great for kite surfing due to their directional nature from sea towards the land, onshore conditions. But what is a sea breeze? When do they occur? Sea breezes occur during hot, summer days because of the unequal heating rates of land and water. During the day, the land surface heats up faster than the water surface. Therefore, the air above the land is warmer than the air above the ocean. Now, recall that warmer air is lighter than cooler air. As a result, warm air rises. Therefore, the warmer air over the land surface is rising. As the warm air over the land is rising, the cooler air over the ocean is flowing over the land surface to replace the rising warm air. Recall that the land surface cools quicker than the water surface at night. Therefore, the warmer air over the ocean is buoyant and is rising. The denser cool air over the land is flowing offshore to replenish the buoyant warm air and is called a land breeze. Sea breezes are local winds that occur in coastal areas due to temperature differences between land and sea. During the day, the land surface warms faster than the sea surface, making the air over the land warmer and less dense than the air over the sea. As a result, the warm air rises and cooler air from the sea flows in to replace it, creating a sea breeze. They are most pronounced on clear, sunny days when the temperature difference between land and sea is greatest. In some cases, sea breezes can also produce thunderstorms, as rising warm air over land can create instability in the atmosphere and trigger convective activity. Ocean breezes can have important impacts on local weather and climate, as they can help moderate temperatures in coastal areas and alleviate hot, humid conditions. They can also have significant ecological impacts, as they can influence the distribution of marine and terrestrial organisms in coastal ecosystems. Sea breezes, as mentioned earlier, are an atmospheric phenomenon caused by the difference in temperature between the surface of the Earth and the surface of the sea. Described below are the steps involved in the formation of a sea breeze. During the day, the sun heats the land and the sea. However, the land heats up faster than the sea. As the land heats up, the air above it becomes warmer and less dense. This warm air rises and creates a low-pressure area over the land. The rising warm air creates a vacuum that is filled by cooler, denser air over the ocean. This air moves toward land and replaces the rising warm air. As the cooler ocean air moves inland, it is deflected upward by the rising warm air over the land. This creates an onshore breeze that is perceived as a cool wind near the coast. The sea breeze continues until the temperature difference between land and sea is equalized or reversed. This usually happens in the late afternoon or early evening when the land has cooled down. At night, the reverse process takes place. The land cools faster than the sea, causing the cool air over the land to sink and creating an area of high pressure over the land. The sinking cool air creates a vacuum that is filled by warmer, less dense air over the sea. This air moves toward land and replaces the sinking cool air. As the warmer air from the sea moves toward land, it is deflected upward by the cooler air over the land. This creates an offshore breeze that is perceived as a cool wind blowing away from the coast. Sea breezes require certain conditions to form. Below are some of the most important conditions that contribute to the formation of sea breezes. Differential warming. For a sea breeze to form, there must be a difference in temperature between the land and the sea. Land-sea orientation. For a sea breeze to develop, the wind direction should be perpendicular to the coastline so that the sea breeze can penetrate inland. Smooth coastline. A smooth coastline with little difference in terrain is ideal for a sea breeze to develop because it allows the breeze to penetrate inland without being disturbed by hills, mountains, or other topographic features. Sunny skies. On clear, sunny days, the sea breeze tends to be stronger and more persistent as the sun heats up the land more quickly. Strong sun angle. The angle of the sun is also important. Sea breezes tend to be stronger when the sun is high in the sky because the angle of the sun's rays is more perpendicular to the surface of the land and sea. Light winds in the air. Light winds at high altitudes can favor the development of a sea breeze. If the winds at higher altitudes are light or calm, the sea breeze can penetrate further inland and be more persistent. Sea breezes are indeed important, especially in coastal regions where they occur. Sea breezes can help regulate temperatures in coastal areas and provide a refreshing change from hot summer temperatures. The cool breezes can help reduce heat stress for people, animals, and plants, and they can also help cool buildings and infrastructure. Ocean breezes can also improve air quality in coastal regions. Onshore breezes can bring in fresher, cleaner air from the ocean and help dilute and disperse pollutants and particulate matter that can accumulate in urban areas. Furthermore, sea breezes can impact marine ecosystems by causing upwelling of nutrient-rich water near the coast. When onshore breezes push surface water toward the coast, deeper, colder water is brought to the surface, providing nutrients for plankton and other marine organisms. Moreover, ocean breezes can also be harnessed to produce power, particularly wind power. The consistent, predictable nature of ocean breezes makes them an attractive source of renewable energy for coastal communities. Finally, ocean breezes can promote coastal recreational activities such as sailing, kiteboarding, and other water sports. The cool breeze can make these activities more comfortable and enjoyable, while providing a natural and sustainable source of energy for sailing and other activities. Causes. Sea breeze. The sea has a greater heat capacity than land, so the surface of the sea warms up more slowly than the surface of the land. As the temperature of the surface of the land rises, the land heats the air above it by convection. The hypsometric equation states that the hydrostatic pressure depends on the temperature. Thus, the hydrostatic pressure over the land decreases less at higher altitude. As the air above the coast has a relatively higher pressure, it starts moving towards the sea at high altitude. This creates an inverse airflow near the ground. The strength of the sea breeze is directly proportional to the temperature difference between the land and the sea. If a strong offshore wind is present, that is, a wind greater than 8 knots, 15 km per hour, and opposing the direction of a possible sea breeze, the sea breeze is not likely to develop. Land breeze. At night, the land cools off faster than the ocean due to differences in their heat capacity, which forces the dying of the daytime sea breeze as the temperature of the land approaches that of the ocean. If the land becomes cooler than the adjacent sea surface temperature, the air pressure over the water will be lower than that of the land, setting up a land breeze blowing from the land to the sea, as long as the environmental surface wind pattern is not strong enough to oppose it. Effects. Sea breeze. A sea breeze front is a weather front created by a sea breeze, also known as a convergence zone. The cold air from the sea meets the warmer air from the land and creates a boundary like a shallow cold front. When powerful, this front creates cumulus clouds, and if the air is humid and unstable, the front can sometimes trigger thunderstorms. If the flow aloft is aligned with the direction of the sea breeze, places experiencing the sea breeze frontal passage will have benign, or fair, weather for the remainder of the day. At the front, warm air continues to flow upward and cold air continually moves in to replace it, and so the front moves progressively inland. Its speed depends on whether it is assisted or hampered by the prevailing wind, and the strength of the thermal contrast between land and sea. At night, the sea breeze usually changes to a land breeze, due to a reversal of the same mechanisms. Thunderstorms caused by powerful sea breeze fronts frequently occur in Florida, a peninsula bounded on the east and west by the Atlantic Ocean and Gulf of Mexico, respectively. During the wet season, which typically lasts from June through September/October, any direction that the winds are blowing would always be off the water, thus making Florida the place most often struck by lightning in the United States, and one of the most on Earth. These storms can also produce significant hail due to the tremendous updraft it causes in the atmosphere, especially during times when the upper atmosphere is cooler, such as during the spring or fall. On calm summer afternoons with little prevailing wind, sea breezes from both coasts may collide in the middle, creating especially severe storms down the center of the state. These thunderstorms can drift towards either the west or east coast depending on the relative strengths of the sea breezes, and sometimes survive to move out over the water at night, creating spectacular cloud-to-cloud lightning shows for hours after sunset. Due to its large size, Lake Okeechobee may also contribute to this activity by creating its own lake breeze, which collides with the east and west coast sea breezes. In Cuba, similar sea breeze collisions with the northern and southern coasts sometimes lead to storms. In the southeast Australian states of New South Wales and Victoria, an intense sea breeze called the southerly buster causes an abrupt, squally southerly wind change, with gusts in excess of 40 knots, 74 km per hour, in coastal cities such as Sydney in New South Wales south to Mallacoota, Victoria and Melbourne, as it approaches from the southeast, mainly on a hot day, bringing in cool, usually severe weather and a dramatic temperature drop, thus ultimately replacing and relieving the prior hot conditions. Marking the boundary between hot and cool air masses, the southerly buster is sometimes represented by a roll-up cloud perpendicular to the coast. The southerly buster is caused by the interaction of a shallow cold front with the blocking mountain range, Great Dividing Range, that aligns the coast, as the cool air becomes trapped against the ranges. The mountains create a channeling effect as the southerly gale winds move across the New South Wales coast, and frictional contrasts over the mainland and the ocean that disconnect the flow. Temperature changes can be dramatic, with falls of 10 to 15 degrees Celsius, 18 to 27 degrees Fahrenheit, often occurring in a few minutes. Land breeze, which consists of cool air coming from the land, pushes the warmer air upwards over the sea. If there is sufficient moisture and instability available, the land breeze can cause showers, or even thunderstorms, over the water. Overnight thunderstorm development offshore due to the land breeze can be a good predictor for the activity on land the following day, as long as there are no expected changes to the weather pattern over the following 12 to 24 hours. This is mainly because the strength of the land breeze is weaker than the sea breeze. The land breeze will die once the land warms up again the next morning. Wind farms are often situated near a coast to take advantage of the normal daily fluctuations of wind speed resulting from sea or land breezes. While many onshore wind farms and offshore wind farms do not rely on these winds, a nearshore wind farm is a type of offshore wind farm located on shallow coastal waters to take advantage of both sea and land breezes. For practical reasons, other offshore wind farms are situated further out to sea and rely on prevailing winds rather than sea breezes. Thank you for watching this video.